بسم الله الرحمن الرحيم. هاي المحاضرة عن اللوكال سيرش والأوبتمايزيشن. المرجع هو روسل بوك Artificial Intelligence Modern Approach. بهذا الشابتر مينلي بدنا نحكي عن اللوكال سيرش algorithms حتى نصل للجينيتيك algorithm. الباث من الستارت ستيت للجول ستيت إذا كان موجود نسميه solution. طبعا هذا الباث إذا كان أحسن واحد فمنطق الألغوريثم نسميها كمان إيش؟ optimal. إذا استطعت الألغوريثم تجد solution فنسميها complete. إذا كان أحسن واحد نسميها إيش؟ optimal algorithm. طبعا لا شك إنه بعض الباثز الألغوريثم ما راح تمشي فيها، يعني بعض الستيتس will be ignored. الالجوريثمز اللي حكينا عنها سابقا حكينا عن depth first search, breadth first search، حكينا عن iterative deepening، حكينا عن A star، حكينا عن iterative deepening A star. اليوم بدنا نحكي عن local search، تحديدا عن hill climbing، نحكي عن genetic algorithm والbeam search stochastic beam search. Reaching the goal is goal satisfaction. Reaching the goal with the optimal path, with the optimal solution based on some objective function is an optimization. Optimization in general, to find the best of something. For example, in some function, finding the optimal value, the maximum value, is an optimization process. Local search keeps track of a single current state, and from that current state it moves to a neighboring or a next state. Mainly I will use a next state instead of neighboring state. It means that not all the states will be visited, so there are some paths will be ignored. This is to save memory, so the space complexity will be less. So we will be able to find a reasonable solution, a tractable solution, a practical solution, especially for hard or let's say big problems. In optimization, all states have an objective function. So each state has an objective function. We compare between the different states using their objective function value. For example, let's say that we have two states, A and B. We evaluate them in terms of objective function. This objective function is somehow similar to heuristic functions that are stated before. Local search algorithms are very good for optimization, especially genetic algorithm, simulated annealing. Some of the algorithms are random sampling and random walk. In random sampling, states are generated randomly. In random walk, neighbors are picked randomly, starting from the current state. So we select the neighbor state from a current state. We select a next state from a current state randomly, a random walk. Hill climbing is a greedy local search algorithm. it has two versions. Maximum version, it means that the hill climbing shall find the maximum value. It will optimize a maximum problem, or it may optimize the minimum, the global minimum selection, or we called it global maximum, or maybe called it global minimum for minimization. We start from the current state. Initially, the first state that you start your search from, you start your hill climbing search from, is called current state. Now, from the current state, we're supposed to select a next state, which is a neighboring state. Neighboring state should be better than the current state. In maximization problem, the value of the neighbor, the height of the neighbor will be more than the height of the current, as we are climbing a hill. In function, if the current point, let's say you call it x1, the neighbor state is x2. So f of x2 or f of neighbor should be bigger than the value of the current. In this way, we may say that we are climbing the hill. On the other hand, for the minimum version, or finding the minimum value, the global minimum, the value of the neighbor should be less than the value of the current. So hill climbing is a continuous process to find the global minima or the global maximum. And because we are talking about a maximization problem, so it is a continuous process towards increasing value, increasing the next state value. It terminates, it means hill climbing stops when the peak is reached. I mean, the maximum value is reached. Assuming that we are trying to find the global maximum. So it is a greedy local search. Comparison between the value of the current state and the next state is based on some objective function, which is similar to heuristic function, as mentioned before. Sometimes hill climbing does not look ahead of the intermediate neighbors, and it can randomly choose among the set of best successors based on the objective function. This can be clear in this slide. Let's say that we start, the current state is this one. As we are moving from left to right, so the next state could be this point, for example. So the value of the next state, this value, should be bigger than the value of the current state. One of the main disadvantages of hill climbing is that it stucks in local maximum, or we simply say that local maxima is one of the main problems, the major problems of hill climbing. It means that hill climbing may find this point as a global maxima. As a matter of fact, it is not. So the main disadvantage, the main drawbacks maybe of hill climbing is local maxima. Plateaus, ridges are two additional problems of hill climbing. For example, in this part, which is called shoulder, or maybe this one, which is flat local maximum, if this is the current state, and this one is the next state, hill climbing cannot discriminate which is better. As a matter of fact, both of them are the same. So this is a problem. Another problem, which is ridges, which is, for example, this point is the current state, which has some value. From this point, you may move to different points, and all of them are not better than the current state. So in this case, hill climbing does not perform well. However, to overcome some of these problems, for example, the shoulders problem, as we maximizing or search for a maximum value, if there is no better move, we may allow some bad move to happen in the hope that the algorithm can recover back and be able to find a better solution. I mean, a better next value. This can be clear maybe again in this slide. Assume that we are in this point. So this is the current state. Let's say this is the next state. Both of them are the same. So what to do? We'll try again. And when we try again, we may reach a better solution. On the other hand, let's say in this state, if this is the current state, this is the next state. The next state is not better than the current state. So let's say, okay, we go to this bad state for some period. After some tries, we'll be able to rise again. I mean, to find some next state that is better than the current state, and hopefully to reach some maxima. This is what is meant by moves in hope that the algorithm can escape from the shoulder problem, or from the local maxima problem. In table search, we use a table list. It is a fixed length queue, a fixed length array maybe. Add most recent states to this queue and drop the oldest. Why? Why are we supposed to do that? As a matter of fact, we make sure that we do not visit the same state more than once. So the hill climbing performance will become better, especially if the tabu list is around 100. The stochastic hill climbing, we make a random selection among the uphill moves. It means that we do not select the best one, we randomly select the uphill move. This selection is based on probability. It means it is stochastic. However, to avoid stacking in local maxima, we may use random walk, random start, or hill climbing, or both of them as a new flavor of hill climbing. When the state space landscape has local minima, any search that moves only in the greedy direction cannot be complete. To make it complete, we make a random walk in which hill climbing may do one of the following two steps. First of all, it works like the original hill climbing, which is a greedy local search with the probability B. The algorithm moves to the neighbor with the largest evaluation value or largest value. I mean the value of the next neighbor will be a better or higher than the current state with a probability of B. However, hill climbing may act randomly by selecting the next neighbor randomly with a probability of 1 minus B, which is the complement of B. It means that if the probability B is 0.3, for example, the random probability will be 0.7, which is 1 minus 0.3. Random start, it means from which initial state shall we start implementing our hill climbing. It means that if you do not succeed to find the optimal value, let's say the optimal maxima, so you start from somewhere else, which is selected randomly. This is some variation of hill climbing. In each start, we run the hill climbing until termination. I mean, until finding the goal or the optimal value, or we run it for a fixed period. Run a fixed number of restarts. Let's say 3 times, but hopefully not forever. So what we concern with is the number of starts and the number of steps in each start maybe. With both, the algorithm will be greedy or random walk or random start. Moves to neighbor with the largest value. This is the original hill climbing. Random walk, move to a randomly neighbor, or moving restarting the hill climbing algorithm from a randomly selected current state, initial state. Thank you very much.